I'm going to write a bunch of functions here, and as I write them, see if you can say what type of function it is. Growth or decay. That's all you have to say, just growth or decay. I'll put a reminder out here. Here's our B line, right, our base number line. So these are the bases. So let's start with this one here. How about I'll write f of x equals 5 to the x. So you just have to say growth or decay. Right, I'm thinking it's growth because what do you know about the base? The base is bigger than 1. And in the exponential function, right, I'll just write it here to remind us, it's b to the x. So if the base is bigger than 1, we're out here, and we get a growth function. Now this is the basic function, right? So I have something, constant to a variable, constant to a variable. Here's another one. What about this one? What if we write, okay, take a fraction like 3/5, raise that to the x. Growth or decay? Well, I'm thinking this one is decay. Why? Because the base, right, I got that basic form, right, a constant to just x, right? There's the basic form, b to the x. I've got b to the x, and what do you know about b? Well, b is between 0 and 1, so that makes it a decay function. And I didn't write it up here, but I will now. That one was a growth function. Let's try this one. How about f of x equals, say, 14.06 to the x? What do you think, growth or decay? Yeah, me too. I'm thinking growth, right? I'm thinking growth because what do you know? Here's the basic form, right? Constant to a variable. That's what I got here. A constant to a variable. And the constant is bigger than 1, so this is a growth function. Now I'm going to write one that's going to cause you some thought here. Now before I write it, here's the basic form, right? You got f of x equals b to the x. So what I want is just a base, a constant, raised to the x. Now it's just x. It's not 5x, it's not x cubed, it's not anything like that. It's just x. B to the x. So what I'm going to write this time is this. I change it. So we'll have to work a little bit harder for this one. What if I say this one is equal to 6 to the negative x? Now this is not the right form, right? Because the form that we're looking at is this form right here. Right here. B to the x. Now what we've got is 6 to the negative x. This does not meet this requirement right here. It doesn't even look the same. So I can change this around because I know some algebra. How about if we do this? This is equal to 6 to the, now it's negative 1 times x, you agree? Now I can write this like this. I can write this as 6 to the negative 1 raised to the x. And you're thinking, what? Where'd that come from? Right, here's what I'm doing. I'm using this rule here. You remember this rule from algebra? If you have x to the n and you raise it to the nth power, what do? You multiply the exponents. So I'm just going this way. What if you have this? What if you have a multiplication in the exponent? What does it mean? It means that you have raised a power to a power. Now that's what I've got here. I've got negative 1 times x, so what did I do? I took 6 to the negative 1 to the x, right? 6 to the negative 1 to the x. Now, what is this 6 to the negative 1? Well, 6 to the negative 1, that's just 1/6 to the x. Now I got the form I want, right? I've got b, which is 1/6, to the x, just 1x. So I've got a fraction between 0 and 1 just to the x. So now, do you recognize this? Growth or decay? This is a decay function. So we've done 4 examples. That's probably enough for now. We'll have a better idea of how to classify these when we look at this down here in the next section. We're going to look at the general form of the exponential function. Not always do the functions look like this, right? This one did not. So how can we tell just by looking at this that it's decay without having to go through all this? Well, we can do that if we know what the general exponential function looks like.